view problem. What's it going to be? It's thermo. So you probably guessed it. All right, let's read this problem together. So we have sodium spontaneously reacting in chlorine gas. Spontaneous. Interesting. Which makes me look down at these answers, and I remember this little equation that we use for thermodynamics. So I don't really know how to use that yet, but let's just keep going. Which of the following statements is true about this reaction? Well, we've got something, we've got entropy, enthalpy, and delta G, so Gibbs free energy. And then we've got these choices. So we need to know the sign. Is it positive or negative? Okay, so this one would be a positive delta S, this would be negative, and this would be positive. Okay. We don't have any data, no numbers. We're not going to actually use this equation to calculate anything. So how do we approach this? Well, the first thing I want to do is go for that word spontaneous. Did you pick up on that when I read the question? Spontaneous means what? That this is thermodynamically favorable. In other words, delta G is not positive, it is negative. So guess what we can do? We can eliminate that answer. So I know that delta G is negative. Okay? And so we can eliminate any of the choices that have possibility 3 in it. Okay, now we get down to enthalpy and entropy. So I want to look at the reaction, and something really stood out to me, and that is the fact that we have a gas. Okay, now what do we know about gases? Gases have very high entropy. In fact, the entropy of a gas is greater than a liquid, which is greater than a solid. Okay, so remember what entropy means. Entropy is randomness or disorder. Okay, and so is my reaction becoming, well, let's see, a positive delta S is going to be what? It's going to be increasing in entropy. In other words, becoming more random. I'm going to write that down. More random, more disorderly. Okay, is my reaction becoming more disorderly? Well, I start off with a solid and a gas, and that is pretty disorderly. And then look what I end up with. I make a solid. What kind of solid? Crystal lattice. It's a very orderly. Wow, it is very orderly. And so is it a positive delta S? Is it becoming more random? No, it's becoming less random, less orderly. Okay, so I just eliminated option 1, okay, which eliminates A and C. Okay, now I'm going to go ahead and circle B, but let's just check and make sure this makes sense. So what is a negative delta H? Do you remember what that means? That means an exothermic reaction. Okay, now does that make sense? If delta H is negative, okay, minus temperature, which is positive, times delta S, which is negative. Track with me here. This whole term right here, negative times negative, will be positive. So I know that enthalpy change has to be negative. Okay, it has to be exothermic because that entropy is working against us. So we know thermodynamically that this one is exothermic, and that's what drives the delta G to be negative. I hope this helps. Hang in there. Thermodynamics. Go through delta S, H, and G, and make a note of what plus and minus signs mean for those variables.